Up until this video, we still don't know the precise number of e. We just know that the number e exists somewhere between 2 and 3. So now we're going to try and track down that number. So consider this limit here. What is the limit as n tends to infinity? So using one of the techniques that we developed, we can always translate a limit problem into a graph problem. So let's translate this limit here into a graph problem. So we can always plot the graph of y equals 1 plus 1 over x to the power of x. Now as to the power of x here. So as n tends to infinity, that's the same as x going to infinity here. So get yourself a graph plotter and plot this. So we want to know the limit of this, but we can always translate this limits problem into a graph problem. So plotting this graph here will give us this. Okay, hang on. Will give us this. So the limit as n tends to infinity here is the same as you looking at this graph and taking x towards infinity. So where is this limit? Where is the limit for this graph here as x tends to infinity? So hang on, let's start again. So here we are trying to find out the limit of this. Okay, so now whenever you have something to the power of something that's moving, so in this case n is moving towards infinity. So here you've got something to the power of n that is moving, where the n is, where the exponent here is moving. So whenever you have something to the power of something, and this power here is moving, then consider using e and the natural log. Okay, so in this case, let's use the natural log. So natural log the whole thing here. So natural log the whole thing. So that will then give you this thing here. So natural log of the limit of blah 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 here. So well, if you natural log the limit of this thing here, that's the same as you concentrating on taking the natural log of just this bit here, and then taking the limit of the whole thing. My point is that starting with this, you want to take the natural log of the whole thing. That will then give you this thing here. But then using one of the laws on limits, we can actually just concentrate on finding the natural log of this whole thing here, and then taking the limit of the whole thing. So well, starting here, natural log the whole thing, that will then give you this thing. But then this thing here is actually the same as this. So concentrate on finding out the log of this thing here. Okay, so really this here is the same as this. Okay, so now just concentrate on this bit here. When you log something to the power of another thing, you can actually move the n down to here. Okay, so that will then give you this. Hang on. That will then give you this. So looking at this here, if you natural log something to the power of another thing, you can take the other thing down to here. So that will give you n and then times this thing here. Okay. But now looking at this here, I want to rewrite this. I want to rewrite this whole thing here in a form that you're familiar with. So let's rewrite this bit here as delta x. Okay, so basically when we are here now, I just want to rewrite this thing here into a form that you would later hopefully would recognize. So let's rewrite this here. So 1 over let 1 over n be delta x. Okay, so this is legitimate because looking at this here, looking at as n tends to infinity. So hang on, I want to rewrite this here as delta x here. Okay, I want to rewrite this as delta x, and it is legitimate because looking at this here as n tends to infinity. So looking at this here. So this here is this bit here. Now as as n tends to infinity, that means n gets bigger and bigger and bigger and bigger. Okay. Now look what happens as n gets bigger and bigger. Look, I want to rewrite this 1 over n as delta x here. So as n gets bigger and bigger, so as n here gets bigger and bigger and bigger, this thing here will get smaller and smaller. This thing here, the whole thing here, the whole bubble here, will get smaller and smaller. That means this thing here is getting smaller and smaller. Okay, so basically, I just want to rewrite this as delta x. Okay, so this here is delta x. This thing here translated to this. So as n tends to infinity, this whole bubble here gets smaller and smaller. Okay, I'm just basically just rewriting this thing here as delta x. Okay, now if 1 over n is delta x here, then this n here, hang on, if 1 over n equals delta x, let's times both sides by n, so delta x times n. Now divide both sides by delta x, so that will give you 1 divided by delta x equals n. Now looking at this here, if you were to rewrite this as delta x, then you must rewrite this n here as then you must rewrite this n here as 1 over delta x. Okay, so hang on, let's start again here. We were here. Okay, we were here. But the thing is, I want to rewrite this whole thing here in terms of something that hopefully later you would recognize. So let's rewrite this thing here as delta x. So that will then give us this thing here. And note that as you increase n, as looking at this, as you increase n here, this thing here will tend to 0. Okay. Now if you were to rewrite this as delta x, then you must rewrite n as 1 over delta x. Okay, so looking at this here, hang on, looking at this n here and looking at this 1 over delta x here. Now let's look at this bit here. Let's look at this bit here. That's this bit here. Now as you increase n, as n gets bigger and bigger here, this thing here gets smaller and smaller. So this bit here will also get smaller and smaller. Now if this bit here gets smaller and smaller, then this whole thing here will get bigger and bigger. Okay, sorry, this whole thing here will get bigger and bigger. Hang on, let's go back one step. Here, if looking at this here, if you were to rewrite this thing here as delta x here, then you must rewrite the n as 1 over delta x here. Now looking at this n and looking at this here, okay, as you increase n here, 1 over n will get smaller and smaller. This thing here will get smaller and smaller. So because it's equals this, then this will also get smaller and smaller. So if delta x gets smaller and smaller, then this whole thing here will get bigger and bigger, which is consistent with this. Because as n tends to infinity, then you would expect this thing here, this n here, will get bigger and bigger. So as n tends to infinity, this block here will get bigger and bigger. So it's consistent. Okay, so it's consistent. Well, if n here gets bigger and bigger, this thing here will get smaller and smaller, and this here, just this bit here, the bottom part, just the bottom part, it will also get smaller and smaller. So as n gets bigger and bigger, this here will get smaller and smaller, and this just the bottom part here will also get smaller and smaller. So we can rewrite this thing here as delta x gets smaller and smaller. So you see, as delta x gets smaller and smaller, then everything's consistent, because looking at this step here, as n gets bigger and bigger, this thing gets smaller and smaller. This thing gets smaller and smaller anyway. So you can actually say that delta x gets smaller and smaller and smaller. So you see, you can rewrite the whole thing here as this. Okay, so hang on. So we were here. We were here. I want to translate this into a form that you would later recognize. But we want to rewrite this here as delta x here. But then if we were to write it as delta x, we got to change the n. We got to change this n here to 1 over delta x here. 1 over delta x. Now, you see this whole thing here. This whole thing here can be translated as this. Can be translated into this. Okay, everything is consistent. You see, as looking at this here, as n gets bigger and bigger, then this thing here gets smaller and smaller, and then this thing here gets bigger and bigger. Okay, looking at down here, I know we changed the n to delta x. I know we changed the earlier we had n tends to infinity. You see, this n tends to infinity thing is the same as delta x tending to 0, because look at this. If you make delta x tending towards 0, this will have the same effect. Look, this thing here will get bigger and bigger, and this thing here will get smaller and smaller. It's the same thing. So hang on. So this thing here, this thing here is really exactly the same as hang on, let me think, as this thing here. Okay, so hang on, this thing here is exactly the same as this thing here. Okay, so we just, well, we're not done yet, so I will continue in the next video. We still got some more to do. So hang on, let me just repeat it one more time. So here, as n tends to infinity here, this thing here will get smaller and smaller, and this thing here will get bigger and bigger. You see, as n tends to infinity. Now we're going to translate this whole thing here into this. Okay, look at this. Even though this thing here is tending to 0, it is still consistent. Look, as this thing here gets smaller and smaller, this thing here will get smaller and smaller, and this thing here will get bigger and bigger. So everything's consistent. So we can say that this here is the same as this. Okay, so we're going to continue from here in the next video. Okay.